in this video, I am not talking about DC. So let us cancel it. So today I am going to just talking about AC. AC with a single element like only resistor, then only inductor and only capacitor. So today we are going to talk about the AC with only one resistor, AC with single inductor and AC with the only capacitor. So here is a single resistor, here is a single inductor and this is a single capacitor. This single resistor is connected across AC supply. And in the second case, I am going to talk about single inductor connected across the AC supply. In the third case, I am going to talk about when a capacitor is connected across the single capacitor is connected across the AC supply. So in today's video, I am going to talk about three cases: the resistor connected across AC supply, single inductor connected across AC supply, and the single capacitor connected across AC supply. In the first case, I am going to talk about circuit containing resistance only. So this is the resistor connected across AC supply. Let us call it as a R. And the value of the voltage, that is a V equals to V naught sin omega t. This is the voltage applied across the resistor. AC supply, in case of AC supply, the voltage is given by not only V, it is given by V naught sin omega t. What is V naught? V naught nothing but peak value of voltage. Peak value of voltage. It is also called maximum voltage. Maximum voltage, maximum value of the voltage. According to Ohm's law, the voltage across resistor is also given by V equals to IR. So we have the V equals to V naught sin omega t. This is the instantaneous value of the voltage. So equation for instantaneous value given nothing but V equals to V naught sin omega t. What would be the instantaneous current? How will you write instantaneous value of the current? So according to Ohm's law, we already have V equals to IR. So I have written V equals to I into R. Call it as equation 1, call it as equation 2. Now we need to find expression for instantaneous current. How to write instantaneous current? We have written the equation for voltage as a V equals to V naught sin omega t. That equation is for instantaneous value of the voltage. So similarly, what is the instantaneous value of the current? How to get it? For that, I am having equation 1 and 2. So comparing 1 and 2. Comparing 1 and 2. When I am comparing 1 and 2, what I get here? I into R equals to V naught sin omega t. Therefore, I equals to V naught upon R sin omega t. Now, V naught upon R, V naught is a constant, R is also constant. Therefore, V naught upon R is a constant. So let us denote it by the I naught. Why I naught? Because V naught is the voltage and R is the resistance. According to Ohm's law, voltage upon resistance equals to current. Therefore, I naught, I denoted by the I naught here. Therefore, what I can write now? I equals to, instead of V naught upon R, I can write I naught sin omega t. So whenever you got the AC, this is a resistor connected across AC supply. So how to write voltage? Voltage nothing but V naught sin omega t. Then how to write the current? Current can be written as I equals to I naught sin omega t. So this is the instantaneous value of the current. So whenever the resistor is connected across the AC supply, you must use V equals to V naught sin omega t and I equals to I naught sin omega t. We need to draw the graph. From the graph, we can get some information. So now we will draw the graph for the current and voltage. That graph is called waveform. Waveform of the current and the waveform of the voltage. Here we are having V equals to V naught sin omega t and I equals to I naught sin omega t for voltage and current. What is omega? Omega nothing but 2 pi upon t, or equals to 2 pi f. What is the t? T is a period. What is the f? F is a frequency. So that implies value of the V depend upon omega and I also depend upon omega. V also depends upon the value of t. T is the time, small t is the time. 1 second, 2 second, 3 second, like this small t stand for the time. So V equals to V naught sin omega t, I equals to I naught sin omega t, where omega nothing but it is the angular frequency. Angular frequency. It is also called angular velocity. Angular velocity. In case of AC fundamentals, omega is called as angular frequency, but when you study the circular motion, the omega equals to angular velocity. Both are roughly remaining the same. The meaning of both is remaining the same, either angular frequency or the angular velocity. The formula for calculating both of them is the same. So here we need to draw the graph. For the drawing the graph, what I do, I take the x-axis here. On the x-axis, here is the 0 angle, here is a pi by 2, and here is a pi, and so on. And on y-axis, I take the two values, one for voltage, another for current, like 1 volt, like 2 volt, 3 volt, 100 volt, like that. I take the values on y-axis. Similarly, 1 ampere, 2 ampere, 3 ampere, 4 ampere, like this. I do take the values on current on the y-axis. Let me draw this diagram properly. It has become so messy. Now we will draw the waveform for voltage and current. For that, on horizontal axis, that is the x-axis, we take the time. So it is a time axis. On horizontal, we take the time. And on vertical axis, we have to consider the two things. One is the value of the current, another is the voltage. So like the 1 volt, 2 volt, 3 volt, like this, you have to take the till the maximum value, like up to the 250 volts. Generally it is between 180 and 230, but here I have written the 250 like this. Now similarly on the same axis, I am going to take like current values like 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere, 10 ampere, like this. So to just make you understand, I have taken here, but these values are taken as far as the graph, because the current generally is very small, like up to the 5 ampere, 10 amperes, 15 amperes, 20 amperes. In very high voltages, in high electrical supplies, high power electrical supply, there you will find high value of current and voltage. But ordinarily in domestic purpose and at small industry level, you will not find like 50 amperes. You will not find. You will find the current value between 10 amperes to 20 amperes or 25 amperes ordinarily. So, but voltage value will be more, like 180 to 230 volt. So this is the general information. And one more thing, we have the here omega t. Now omega is nothing but 2 pi upon t. So what values of t we can select? you see we'll start with 0. So t equals to 0, everything is 0. And second case, we can take the little higher value, that is t upon 4. This and this cut down. Here we'll get the pi by 2. So first we'll get the 0, and after that here is a pi by 2, and after that 2 pi upon t. We can take the t value, half the value, t by 2. So here 2 cut down, t cut down, we get the pi. So here we get the pi, and after that 2 pi upon t, and now little bit increase, t by 2 plus t by 4, that is 3t by 4. So you can take now 3t upon 4. This t get cancelled and this get cancelled. So we get the 3 pi upon 2. So 3 pi upon 2 like this. It will be, the values are taken on the x-axis. Here is a V equals to V naught. So V naught is the peak value of voltage, that is the maximum voltage. So let us take this value as a maximum voltage V naught, and I naught, that is the peak value of the current. So let us take the here value I naught. Now when t equals to 0, V equals to 0, as well as I equals to 0, because sine 0 value is 0. If you put into this equation sine omega t, so sine omega into 0, sine 0 equals to, everything is 0. Therefore at t equals to 0, the value of the voltage is 0, value of the current is also 0. So both the graphs start from 0. One more important information, that the largest value of sine theta is 1. Therefore that occurs when sine 90 equals to 1. So largest value of voltage, that is a V naught into 1 equals to V naught, and largest value of current I equals to I naught into 1 equals to I naught. These are the largest value. So largest value occurs when small t equals to t by 4. Also we can say the omega t value equals to pi by 2. Therefore on time axis we can also say it is equivalent to omega t axis. So at omega t value equals to pi by 2, we get the maximum value, or the t equals to pi upon 4, we get the maximum value. Same case for the current and voltage. Therefore both the graphs, the graph for voltage start from minimum value and achieve the maximum value at omega t equals to pi by 2. Similarly, the current becomes maximum at omega t equals to pi by 2. Here, from here, both are becoming maximum at omega t equals to pi by 2. We know that sine pi equals to 0. Therefore, at omega t equals to pi, V equals to 0. Therefore, the voltage becomes 0 at omega t equals to pi. Similarly, the current will become 0 at omega t equals to pi. If we continue the calculation and draw the graph, then we get the graph like this. For voltage and for current, the graph will become like this. So these are the graphs. They are not graphs, we call them as a waveform. So these are the waveform for the voltage. This upper one is for voltage and this lower one is for the current. Here one observation. What is that? You see both the waveforms started with 0 simultaneously. Both the waveforms became maximum simultaneously. Again both the waveforms became zero simultaneously. Here also in the negative cycle, same thing happening. Both the waveforms attaining their peak values and zero value simultaneously. We say both waveforms are in phase. Now, one more diagram called as a phasor diagram. In the phasor diagram, we got a baseline and another line is a vertical line. On the vertical line, we write down the value of I naught and also write down the, so we take the peak value of the current and voltage in the phasor diagram, and we draw the vector for the current and voltage according to their magnitude. So, and we also take down the angle. Angle is the omega t at a given instant of time. The angle is omega t. So I have drawn, this is the graph for current, and this angle is omega t in anti-clockwise direction. We taken the angle in the anti-clockwise direction, and this vector diagram stand for current. Therefore, it is called phasor of current. Phasor diagram of current. Now we draw the phasor, the vector for voltage. The peak value here V naught. So here is a peak value V naught, and we extend this line till it cuts the horizontal line of V naught. So this is another phasor. This phasor is nothing but called voltage phasor. Phasor diagram for voltage. And so the diagram in which we draw the vector diagram showing the magnitude of current and voltage, and we also show the angle, that is omega t, then such diagrams is called as a phasor diagram. So in this discussion, what we have learned? We have learned that whenever the resistor is connected across AC supply, then the current and voltage values vary equally. They become zero, they become maximum, and they become minimum at the same instant of time. Therefore, for the circuit in which the single resistor connected across the AC supply, V equals to V naught sin omega t, then current and voltage vary together. So we can say the current and voltage are in phase in AC circuit with a single resistor. Now case 2. In case 2, I am going to talk about circuit containing only inductor. L is the inductor, and how much voltage is applied across it? V equals to V naught sin omega t. This is applied voltage across the inductor. L is the inductance. When we apply some voltage, AC voltage across the inductor, then what happens? There is some opposing voltage is produced in the coil, that is called as a back EMF. So the back EMF, the value of back EMF, magnitude of back EMF is given by L into di by dt. What is di by dt? Di by dt nothing but rate of change of current. Rate of change of current. What exactly the back EMF? We'll see in the next video. But whenever we apply some AC voltage across the inductor, there is always something called back EMF is produced. The magnitude of back EMF is equals to applied voltage. What is the value of back EMF? L into di by dt. L into di by dt. And what is the applied voltage? V naught sin omega t. So back EMF is always equals to applied voltage. We know the applied voltage, that is V equals to V naught sin omega t. We need to find how much current is flowing through the inductor. To find the value of the current, we have to do some adjustment here. First of all, di by dt equals to V naught upon L and sin omega t. After this, we need to find the current. So di by dt equals to V naught L upon L sin omega t. Rearranging, di equals to V naught upon L sin omega t multiplied by dt. So left side is a di and the right side is the dt. the differential terms are there. So what we can do, we want to find current. To find whenever there is a derivative, di by dt is a derivative. So to remove the derivative, what you do? You do the integration. So integrating both sides. Whenever the derivative terms are there, to delete them, to remove them, we have to do the integration. So integrating both sides. So integration of di equals to integration of v naught upon L sin omega t with respect to t. Integration of di is equals to I, and v naught is a constant, L is a constant. Integration of sin omega t with respect to t. Therefore, I equals to v naught upon L, and integration of sin omega t, nothing but minus cos omega t upon omega. So I equals to v naught upon omega L minus cos omega t. Now expression for voltage, that is the v equals to v naught sin omega t. So this is applied voltage given in terms of sin omega t, and the expression for current we got in terms of cos omega t. So comparison is little bit uneasy, not possible. So we have to convert expression for the current in terms of sin omega t only. Cos omega t will not do. So to convert cos omega t, we got an idea, trigonometry, that is a sine of 90 minus theta equals to cos theta. That means cos theta can be written as sine of 90 minus theta, and minus cos theta can be written as sine of minus 90 minus theta, this way. So minus cos theta can be written as sine of theta minus 90. This way we can write down. So therefore we have the cos minus cos omega t, that can be written as a sine of omega t minus pi by 2, because 90 degree is equals to pi by 2. Therefore in place of this minus cos omega t, remove this, and in the place of this write down sine omega t minus pi by 2. Therefore I equals to v naught upon omega L into multiplied by sine omega t minus pi by 2. One more thing, v naught is nothing but voltage, and omega L is something resistance. So voltage upon resistance is equals to current. Therefore v naught upon omega L is nothing but I naught. Therefore this expression I equals to v naught upon omega L can be written as I naught into sine omega t minus pi by 2. One more thing, I said omega L equals to resistance, but it is not called resistance because it is an inductor. Therefore the technical name given to this resistance is not resistance, it is called inductive reactance. It is called inductive reactance. And v naught upon omega L, this gives the maximum value of current. Maximum value of current. Therefore I have denoted by I naught. Therefore finally we got expression for current I equals to I naught sine omega t minus pi by 2. I have redrawn the circuit here. So the applied voltage across the inductor is given by V equals to V naught sine omega t, and the current flows through the inductor is given by I naught sine omega t minus pi by 2, sine of omega t minus pi by 2. Now let us draw the waveform diagram and phasor diagram for this circuit. So first of all, plot the all values along the omega t axis and the voltage and current vertically. Now let us, I naught is a peak value of the current and V naught is a peak value of the voltage. We need to draw the waveform diagram. Expression for the voltage is V equals to V naught sin omega t. So it is a regular diagram. First of all, plot this like this for pi by 2, for pi, and for 3 pi by 2, and for the 2 pi like this. Even in the downward direction, let us take this is the V naught. So first of all, let us draw the waveform diagram for V equals to V naught sin omega t. So this is regular diagram as we drawn in earlier case, like this. So this is waveform diagram for V equals to V naught sin omega t. Now we need to draw the waveform diagram for current. To plot waveform diagram for current, let us take first of all value 0. Okay, omega t equals to 0. Then what do you get here? I equals to I naught. Here is the 0 minus pi by 2. So I equals to, here is the sign, sorry, I sin of minus pi by 2. So here is the I naught. Therefore minus I naught into 1 equals to minus I naught. Implies when omega t equals to 0, I equals to minus I naught. So here is a minus I naught at t equals to 0. So I got the point number 1 here. So first of all, let us plot the points. Then we will join to get the graph. As we did in the 10th standard, we used to draw the graphs. The same way I am trying here. Now after that, let us take omega t equals to pi by 2. Then I get here I equals to I naught sin, in place of omega t, write down pi by 2 minus pi by 2. So I equals to I naught into sin 0. Sin 0 is nothing but 0. Therefore I equals to 0 at omega t equals to pi by 2. That is, this is the point. So we got this is the second point. After that, we will be joining all the points. And after that, let us take pi. So omega t equals to pi. When omega t equals to pi, what do you get here? I equals to I naught sin pi minus pi by 2. So that is I equals to I naught into sin pi by 2. That is I equals to I naught into 1. Therefore, at omega t equals to pi by 2, I value is I naught. So I value I naught. So at pi, so I naught it is here. Now we will join these points like this, like this. And after that, the fourth case, let us take omega t equals to 3 pi by 2. So I get here I equals to I naught sin 3 pi by 2 minus pi by 2 equals to I naught sin 2 pi by 2 equals to I naught into sin pi. Sin pi is 0. Therefore I equals to I naught into 0 equals to 0. Therefore at omega t, at omega t equals to 3 pi by 2, I equals to 0. So that is the next point here. So what we'll do now, we'll join this point, and so on. You keep on joining them. So you will get the graph like this. Okay, the graph will go on like this. After drawing these graphs, that is the waveforms, after drawing the waveform, we can get some characteristic behavior of inductor circuit. In inductor circuit, you see when current is 0, here was the current is 0, I equals to 0, and that time when the current is 0, the voltage was maximum. So when current is 0, the voltage is maximum. Implies what? Implies the voltage is leading and current is lagging. What is that? Voltage is leading and current is lagging. By how much angle? By this much angle. You see this is a pi by 2. So we say the current lags, current is lagging voltage by an angle of pi by 2. So in inductor circuit, current is lagging and the voltage is leading. We have the expression for voltage, that is V equals to V naught sin omega t, 0 plus omega t. Omega t can be written as a 0 plus omega t. Therefore, the vector diagram for the voltage across the inductor, applied across the inductor, can be drawn. How much value? Magnitude equals to V naught. So this is the V naught value. This is the vector for, we can say, the phasor diagram for voltage, that is a V naught. Now, how to draw for current? Now, we can draw the phasor diagram for current. So, current is given by I equals to I naught and sine. This can be written as 0 minus pi by 2. That means minus pi by 2 degree away from 0. And the voltage was omega t away from the 0. So, this was the angle omega t. And for the current, suppose this is I. And the maximum value of the current is I naught. This is a vector diagram for current. We can call it a phasor for current. So this value is I naught. And what is the angle between current and voltage? That is 90 degree. Thus, in a pure inductor circuit, current lags behind the voltage by a phase angle of pi by 2, that is equals to 90 degrees. Till now, we considered the two circuits. One was AC circuit containing only resistor. Second case was AC circuit containing only inductor. Now the third case is the last case, in which I am going to talk about AC circuit containing only capacitor. Now let V equals to V naught sin omega t be the alternating voltage applied across the capacitor. And the value of the capacitor is nothing but, capacitance is nothing but C. What is the capacitance? It is the ratio of charge to the rise in potential. Therefore, we get V equals to Q upon C. So we have the two equations now. One is the V equals to V naught sin omega t. Another is the V equals to Q upon C. Since we have not connected any resistor in the circuit, so the potential difference between the plates of capacitor is equals to applied alternating voltage. Therefore, V equals to V naught sin omega t, and V also equals to Q upon C. So implies Q upon C equals to V naught sin omega t. So we have Q upon C equals to V naught sin omega t. Therefore, Q equals to V naught multiplied by C sin omega t. Here we have the voltage V equals to V naught sin omega t. What do you want? You want the current I. So, but we don't have current, we have the charge. So how to get the current? We can get the current because we know that current is nothing but rate of change of charge dq by dt. That means to get the current, we have to differentiate both sides with respect to t. So differentiating both sides with respect to t. Differentiating both sides with respect to t. So we get dq by dt equals to differentiation of v naught c sine omega t with respect to t. But dq by dt equals to I. Therefore, I equals to, what are the constant? C is the constant, V naught is the constant. So they are taken out of the differentiation. Now we need to do derivative of only sine omega t. So the derivative of sine omega t is nothing but omega into cos omega t. So we have I equals to V naught into omega c into cos omega t. The expression for voltage, alternating voltage, that is the instantaneous voltage applied across the capacitor, is given by V equals to V naught sine omega t. So it is expressed in terms of sine, and current we got in terms of cos. So both are not same trigonometrical functions. So to convert the cos omega t, we have to convert cos omega t in terms of sine. So how to convert that one? So we know that sine 90 plus theta equals to cos theta. Therefore, sine 90 plus omega t equals to cos omega t. Therefore, I equals to V naught multiplied by omega c, and in place of cos omega t I can write sine, and in place of pi I can write pi by 2 plus omega t. Therefore, the current across the capacitor is nothing but given by V naught divided by 1 upon omega c multiplied by sine of pi by 2 plus omega t. So I equals to V naught upon 1 divided by omega c sine, and here pi by 2 plus omega t can be written as omega t plus pi by 2. And LHS is the current, so RHS has to be current. So here is a V naught divided by something. So this quantity has to be equal to I naught. So implies 1 upon omega c is equals to resistance. But for the capacitor, we don't use the word resistance. We use the word reactance. So it is a capacitor. Therefore, 1 upon omega c is nothing but called as a capacitive reactance. Capacitive reactance, and it is denoted by Xc. Therefore, I equals to V naught upon Xc sine omega t plus pi by 2. So I equals to V naught upon Xc can be denoted by I naught. So I equals to I naught of omega t plus pi by 2. Now we have the V equals to V naught sine omega t, and the current I equals to I naught sine of omega t plus pi by 2. By using these two equations, we can now draw the waveform diagrams for voltage and current. And for instantaneous value of the voltage, we have the equation V equals to V naught sine omega t plus 0. So suppose I put omega t equals to 0, V equals to V naught sine 0 plus 0. So that is V equals to 0 at omega t equals to 0. And after that, let us put omega t equals to pi by 2. So V equals to V naught sine pi by 2. That is equals to V naught, implies implies V equals to V naught at omega t equals to pi by 2. Let us draw the waveform for the instantaneous value of the current. So that is I naught sin omega t plus pi by 2, and it is maximum at omega t equals to 0 and 0 at omega t equals to pi by 2. That is I equals to I naught at omega t equals to 0. Therefore, this is the point, and I equals to 0 at omega t equals to pi by 2. Therefore, joining like this and like this, then the graph will be continued and will move like this. So this is the graph for I. Now V equals to V naught sin omega t. So it is a original equation. Therefore, graph for voltage is same as original, like this, like this. So this is the graph for voltage, instantaneous value of voltage. It is a waveform. Don't call it as a graph, call it as a waveform. So waveform for voltage and current we got here. What is observation? When the voltage is 0, the current is maximum. That is observation. Here we do observe that the current reaches its maximum value first, after that the voltage. So the expression for voltage is omega t plus 0, and for current omega t plus pi by 2. So there is a phase angle. The difference of phase angle is pi by 2, implies current is leading the voltage by an angle of pi by 2. Now let us draw the phasor diagram for voltage. It is a V equals to sin omega t plus 0. So phasor diagram is a vector diagram, and this is nothing but its magnitude, and this angle is omega t plus 0. So this is for phasor diagram for instantaneous value of voltage applied across the capacitor. And for current, it is omega t plus pi by 2, omega t plus pi by 2. So it will come here somewhere, I naught. So it is this angle is equals to omega t plus pi by 2. So this is a phasor diagram for the capacitor connected across the AC supply. So it is a phasor diagram. So in a perfect capacitor, the current leads the voltage by a phase angle of pi by 2. That is, current leads the voltage by an angle of pi by 2.